at SAMS, we like to be at the forefront of finding new ways to conduct scientific research. A new and exciting project we've recently become involved in involves the use of remotely piloted aircraft, or RPAs. This involves attaching scientific instruments for measuring and cameras to aircraft and then flying them over the sea surface. It provides a fast and efficient way of collecting a lot of data. Come and see what it's all about.
So, can you tell me exactly what an RPA is?
Well, in its simplest case, an RPA like this one is just a remote control aircraft. What makes them better than just a standard remote control aircraft is a built-in autopilot functionality, which means you can set them on a programmed mission to follow GPS points at various positions and altitudes, and it will just fly off on its mission and do what it is you need it to do. The motor sits at the back. We launch it using this cord here connected to a bungee, so we just walk back and fire it up in the air. On board it has, the battery sits there, the receiver and the autopilot electronics sits there. It can have various sensors mounted all over it for air sampling and cameras. You can modify it as and when you need, put different bits and pieces on it. And yeah, it can flight duration of a couple of hours, payload of a couple of kilos, and obviously those ratios change depending on how heavy it is and how long you want to fly for. This is the simulator where we learn to fly the planes, hone our skills and practice crash landings.
We're in the centre of Amble in Northumberland on our way to the training centre for Quest UAV. Let's go inside and see what the team are up to. So Nigel, what can you tell me are Quest UAV's aims for the use of RPAs?
Right, we have got quite a significant number of aims that we're after. One is to continue our work on land, but also to move onto the sea, working with normal cameras, working with infrared cameras, multispectral, and other sensors that might have applications in atmospheric science, but generally staying within the bounds of research, staying out of military, staying out of surveillance, and into the environmental applications.
We've come to a big field where hopefully we're going to get to see some of the planes fly. Can you just explain to us a little bit about what the guys are doing just now?
Yeah, certainly. We're on day 3 of a training course with SAMS. Day 1 we came out and did a little bit of flying here just to be an introduction to the flying. Yesterday was a day in the classroom, so today is a kind of culmination of what they learnt on the first day of flying plus their ground skills. So they have got their 2 UAVs here and now, which they're working on, just doing the tests. They're going to be flying in about 5 minutes, doing a route around the sky that they have planned on the laptop, and just going to check that it all works and all goes fine.
Before we fly the UAV, we have to do certain pre-flight checks to ensure that the conditions for takeoff are met and that the site is safe and that the aircraft is ready for flight. One of the things we do is obviously measure the wind to make sure it's within the flying limits, and this is all done prior to takeoff.
3, 2, 1.
Ready, go.
Okay, it's approaching waypoint 8. Do you want to take it now?
Yep, I've got it.
Good. Yeah, 90 feet, 44 knots. 34 knots.
So, if that's that,
85 feet.
And Jim, shout out your intentions.
Right, I'm just going to go around, circle to the right.
75 feet, 40 knots. Yeah, 75, 70 feet, 32 knots.
Then I'll power up and fly by.
see them going in the future? You know, what are your aspirations?
Larger, higher, greater endurance, greater distance, greater resolution, more accurate research coming out of them.
Now it's time to fly back to SAMS to see how the scientists there are using RPAs in their fields of research.
And one thing that in invasion biology is this sort of natural dispersal of species, of invasive species, we know very, very little about. These RPAs would be absolutely fantastic to conduct sort of aerial surveys of these mats, of giant mats, up to sort of 2, 3, 10 metres in diameter. They could conduct these aerial surveys to see where and how fast these natural mats of invasive seaweeds are actually spreading.
What we here at SAMS would like to use the technique for would involve studying the distribution of whales and dolphins in tidal streams such as the Gulf of Corryvreckan, the Cowray, the Pentland Firth, places like that.
So my interests are in things that happen in the surface of the ocean, just beneath the surface, the top metre or so of the ocean, and RPAs will give us a new insight into some of those processes, not only because you can fly very rapidly with an RPA and cover a lot of ground very quickly, but also things that you see from an angle when you stand at the side of the ocean. If you look straight down, you see very differently.
The aquaculture industry at the moment in Scotland is quite concerned about increases in jellyfish around fish cages because they can cause lots of problems for the fish. And we really don't know very much about the abundance of jellyfish, where they're coming from, seasonality, and we're hoping that we can use the remote controlled aircraft to survey fairly large areas of sea for surface cruising jellyfish at least.
So you've seen a variety of uses of RPAs, and it's clear to see that they can be very valuable for scientific research. It's likely that RPAs will play an increasing role in marine science advancement, and we're proud to say that SAMS is a part of this.
Oh, my name is Cote, me boys, me age is 53. For 25 or 30 years I fished upon the sea. But now it seems a waste of time, the catches they grow small. The foreigners take the biggest fish and go back on small.